Right, I will start. Design of solar pump using PVSys software. So generally we know already this pump is used to supply the water for your residential application, industrial, agricultural, irrigation application like that you can use anywhere. We have traditionally we are using the AC type. There are DC type pumps also there and surface type pumps also there, submersible pumps also there. Here we are using the pump which works based on the input that is solar energy. We know when solar light energy falls on the solar panel, then it will be converted into the electrical energy, the complete operation you know. So we will get DC. The DC is given to the pump. Okay, here if it is AC pump, then you have to choose here inverter. Okay, that inverter converts DC to AC. If you are choosing DC pump, then here it should be charge controller. Okay, charge controller, you know, charge controller function is to avoid the over voltage and discharge, voltage and overcharging and over discharging. And this is standalone type. This is not connected to grid, so you can use the grid for safety purpose. You can use the battery. Then the pump fill the water in this overhead tank. Then it can be used for your purpose. This is the basic operation. So here to design the solar pump, okay, here this is I am showing, this is the ground. Here the overhead tank is placed and this is deep well. Different types are there. This is deep well type and this is the pump. This pump sucks the water and fills into the your overhead tank. This is the maximum water level and this top of this water level to ground is called as the, from this point to this point is called as the static head, and from ground to your overhead tank it is called as the suction head. Okay, so you have to add all these heads. So we are choosing the static head, or it is also called as static level 40 meters, and this height of the overhead tank, it will be nothing but the suction head, that is 7 meters. And we are using this pumping water to some farm like wheat. Here for example I am considering the wheat. So each and every farm has its own water consumption. You have to know an idea how much of water is required per day or per year for wheat or for mango, for tomato, for onion. There are different types of fields. So first you have to know the idea. Here I am considering the field area 30 acres of wheat, and as per my knowledge, the water consumption for each acre of wheat is 40 meter per day. So we have considered 30 acres, so 30 into 40, 1200 meter cube per day. So this is the first step. We have to calculate the amount of water needed per day. Then after, you have to calculate the water flow rate. Okay. This water flow rate is depends on the peak hours, sun peak hours. How can you calculate? In the last two sessions we discussed. So solar radiation generally measured in kilowatt hour per meter square per day, and at given location, you know, the solar radiation 5 kilowatt hour per meter square per day. So just I am assuming it is changes location to location, then divided by standard testing condition irradiation, you will get 5 hours per day. So water flow rate generally it is represented by Q. So that is the ratio of what? This one, total amount of water required per day by peak hours, that gives 240 meter cube per hour. So per hour the water flow rate should be 240 meter cube. So with this rate it fills the water tank. Then you have to choose the pipe diameter. So there are some specifications are there. for according to the maximum rate of flow in meter cube per, for 2.25 it is 3 by 4 inches like that. So consider this table, and we have the 240 meter cube per hour, it is near to 250, so pipe diameter like you can take 6 inches. Okay. Pipe diameter is 6 inches. Now you have to calculate the total dynamic head. Total dynamic head is calculated to determine the pump sizing. Pump sizing generally taken in the horsepower. So we have to calculate the how much of horsepower of pump is required. For that, before you have to calculate total dynamic head. Total dynamic head is nothing but the static head plus suction head plus friction losses. Static head means what? Static head means from this top of water level to from ground surface. Suction head means this one. So here 40 plus 7, 47. But you have to calculate the frictional losses. So you are using some type of material, pipe material. Based on the pipe material, the frictional losses will be changes. So here different types of pipe materials are there. Then for different types of material, there will be some coefficient. You have to use this coefficient C, that is called Harisun coefficient. Right? So this is the frictional loss formula. This is already predefined formula. So we have to this formula having the terms like Q flow rate in meter cube per second, pipe diameter, length of pipe, friction factor, and coefficient. So all the values we know Q value, we know pipe diameter. You can choose the length of the pipe, that should be more than this. So I am choosing the pipe length 50 meters, and I am choosing C value 150, but because I am choosing the material PVC. So after substituting all these values, you will get frictional losses in meters, that is 0.297. Now you can get the total dynamic head, what is plus 7 plus 0.297. So that Hazen-Williams coefficient value depends on the pipe material. Okay, that is depends on the pipe material. We have the specification like for PVC material it is 150, for asbestos cement it is 140, for welded steel it is 100. I am assuming my pipe material is PVC, so I will choose C equal to 150. Right. Now, so after substituting this, you will get 0.297. Therefore, total head equal to 47.297. Now you can calculate the pump power. So we know all this. Total dynamic head TDH, Q value know. Pump efficiency I am assuming 85%. So I am substituting all this. Then pump power required equal to 36.39. Actually, it should be in the horsepower. So to convert into horsepower, you have to divide it by 746. So you will get 50 HP required. Right. Now in the next step, you have to calculate the pump size is okay. Now we know this water needs. These are called as the water needs. Water needs side, you know specifications. Now you know pump 50 HP. Now you have to, if you are inverter, you are using inverter, then you have to size the inverter. Okay. Again, if you convert 50 HP into kilowatts, you will get 37.3, and assume the efficiency, inverter efficiency 85%. You can choose the inverter efficiency 90 or 95 also, that is up to you. Based on the efficiency, the sizing will be changes. So 37.3 by 0.85, that will give 43.88 kilowatt. So you can use up to 44 or 45. So solar power required is how much now? 45 kilowatt. Now for with respect to this 45 kilowatt, we have to choose the inverter. So I have chosen the inverter, solar pump inverter of this model. So I will show this model specifications. So see, I have chosen this model. Okay, I have chosen this model. So this is SPI solar pump inverter 200 40 37B. That means rated power is 37 kilowatt. This rated power is 37 kilowatt, and this is what this 800 is the operating voltage, that is input voltage to the inverter, and this 450 to 800 is the MPPT voltage, maximum power point tracking voltage, and here it will be available for 50 hertz and 60 hertz, and DC power you will get from this 48. The DC power actually required, sorry, the DC power required is 48 kilowatts, and rated power of this inverter is 37. That means to meet this solar power of 45 kilowatt, this is suitable. So the rated power of 37 kilowatt is suitable. Okay, rated voltage is 380 to 440 volts. Recommended PV input power is 48 kilowatt, and tracking voltage is 450 to 800, and DC input voltage 800, and rated current is 71 ampere. This is your inverter specification. Now, how many number of panels are required? How many panels are required? So you can choose your own panel rating, 300 watt, 400 watt, okay, 150 watt, like that. I am considering 250 watt panel. 250 watt panel has the open circuit voltage of 30.53 volts, 8.19 ampere. And so how can you calculate number of panels? Actually the solar power required is 45 kilowatt. So 45 kilowatt by 250, that gives 180 panels. So 180 panels are required. And how many strings are required? So that will be, you can use the rated current 71 ampere. This is the total current. So if you are connecting in the number of parallel strings, then current will be added. So that's why you can choose this 71 ampere rated current to find out the number of parallel strings. So 71 by how much? 8 point. All the modules connected in series, then current will not be changes. 71 by 81, 8.19, that will give 8.669. I will round it to lower value, that is 8. Why? Because if you go for the higher value, it may be more than 71 ampere. So I am choosing to 71 ampere. And in each string, so how many panels are required? How can you calculate? 180 by 8. 8 number of strings. So in each string 23 panels are required. Right. Now you can verify. So whether this voltage is in the operating range or not. So 23 into 30.53, 702.19, that is in operating range, 450 to 80, 800. So it is okay. And if you nominal power, you will get 250 each module power. So how many panels are there? 250 into 180, you will get 46 kilowatt. So like this, you can design your solar pump. Now, so this is solar pump design. Now you can go to the PV software. So in the up to now it is okay. Up to now it is okay. Right. So the theoretical calculations up to now we have discussed. Now you can design your solar pump using the PV system software. So here each and every step I kept in the PPT clearly. So I want you to design yourself. I will give this PPT already designed, and each and every step I have taken the snapshot. I want you to design yourself. Is it okay for you, or I will explain this? Can I explain? Each and every step clearly I mentioned in the PPT. Okay. I want you to design yourself. It will be it will be practice for you. Okay. Take it as some assignment. Take it as some assignment. Then only it will be practice for you. Otherwise, if you want to explain to me, I will explain. Why? Because everything, every step, clearly this is the first. Okay, I will explain in the PPT. So first what you have to do? You have to insert your location database. So whatever, if you are locating in the Hyderabad, then choose the Hyderabad location. If you are locating in some rural area, then locate that rural area database. Okay, then what you have to do? Remember, all of you, after locating the this database, immediately you have to save the project. Then only all this will be enabled. Okay, so every step you have to see the message. This is the message box. Okay, you can see here ready for simulation. Why? Because everything is good. That's why you are giving the message. Each and every step you will get some message. Either it may be warning message or error message. You have to definitely you have to read that message. Okay, then only you can understand whether I have to go for the further step or I am stucking at the same step. You can understand. So after inserting database, now you have to click on the save project. Then all will be enabled. Then first you will give the orientation. It will give the message like go to the orientation like that. So click on orientation. Then you have to choose your tilt angle and azimuth angle. Okay. So that is based on how can you choose the tilt angle? Tilt angle is equal to your location latitude. So if your location latitude is some 18 degrees, then where is that latitude? So increase or decrease, and increase or decrease the latitude and check whether this energy is collecting by the solar panel is increasing or decreasing. So if it is increasing, choose that value here. Okay, so that will be the, so the importance of latitude is it is the near optimum angle. So it will give the idea. So 18 is the optimum near optimum angle. So increase or decrease that one, you will get the energy collected by the solar module. And then click on OK. So here, so when you click on OK and see here, then you have to go for water needs. Click on water needs. When you click on water needs, you will get this window. Here you have to choose deep well to storage. Okay, this is the type of deep well to storage. Now you have to enter the what are the values we have chosen in our example. Take static depth is 40 meters. Okay, and maximum pumping depth. This is the maximum pumping depth. So we have chosen the static depth. It is up to this only. Okay, so your pump will be go under deep, and it is touches to the last point of ground. So you have to choose that distance also in meters, that is 43, and pump depth should be more than this 44, right? Like that you have to, this is the storage tank. We have chosen what is the flow rate, 240 meter cube per hour. So your storage tank is also same as equal to 240, and diameter 6 inches we have chosen, right? Sorry, diameter of tank. Diameter of tank, it will be automatically chosen when you enter the water flow rate. Diameter of tank it will be chooses, and water full height we have chosen 7 meters, and altitude also same. Now we have chosen the, this is the pipe diameter. Okay, so 6 inches diameter. This 6 inches the pipe diameter, and this DN 150 nothing but diameter normal. DN means diameter normal, of 6 inches, and we have chosen the length 50 meters. Like that you have to enter. So here you can take this reference and open the each and every window, enter the same values. Next, go to the here in the same window. This is water needs. Sorry, this is pumping hydraulic circuit, and click on the water heats. Then you will get this one. So here, for whole year, it requires and it requires 200 meter cube per day. And static depth you can choose for whole year same 40 watt. Sorry, 40 meters. Next, click on OK. Then here you have to define the system. So, right after completing this water needs, click on the system. Click on the system, then you will get this window. So here when you open this window, then this will be here after based on your water needs, it will suggest you hydraulic power. This is defaultly you will get hydraulic power 31.3 kilowatt, and suggested power is 1 or 2 kilowatt. It is near to our values. You can check and choose the solar panel. Okay, choose the solar panel type of manufacturer. Here I have chosen some different company like Trina Solar 250 watt peak of voltage 25 volts. This is at maximum temperature, and you have to choose the inverter. Okay, what is the inverter you have chosen? 37 kilowatt. Okay, so that is you have to choose. And when you enter this PV module and inverter, then it will give the array configuration. So you can check, we have got 180 modules. Here also we have got 180 modules of how much area it is requiring? 296 meter square. Okay, and this 180 into 250, that will give the nominal power 45 kilowatt. This will be suitable to your problem, design problem. Next, you have to choose the pump. So we have chosen the 37 kilowatt pump. Okay, why? Because here we have got the same value, but in HP it is how much? 50 HP, like that. So choose this model. There are different types of pumps. Okay, we have chosen the centrifugal pump and click on OK. So when you click on OK and you don't get any message here, so you will get, finally you will get this window. Here you don't get any message, and it says the message like ready for simulation. Then click on the run simulation. What will happen? It will give simulation successfully completed. Then here see, this is the report. This will be enabled. Okay, and you will download the report and you can verify that one. So this is the detailed procedure I given. Okay, I want you to try this at your home. Why? Because it will be practice for you. Everything is given. Will you do, all the people, will you do this one? Any differences for meteor database for rooftop and ground mounted? Meteor database, it will not changes. It is always for location, it will be fixed. For any type of mounting, it will be fixed. For any type of mounting, the meteor database for a location, it will not be changes. It will be fixed. Yeah, I will share the PPT. So you want to design any plant, either 10 kilowatt plant or 100 kilowatt plant, 1 megawatt plant, you have to, whatever the design consideration we have done, you can do for any plant, 10 kilowatt or 100 kilowatt, anyone, 1 megawatt or 10 megawatt. The design procedure will not change. So you people, I hope you people will do on yourself this design of solar pump, I think. Yeah, I will share the video tomorrow. I will share the recordings tomorrow. Tomorrow is the last day. I will share the PPT also. Sir, in the PPT I mentioned everything, sir. The recording, I think it is not required now. In the PPT, each and every step I included. With the, if you follow this PPT also, you can do on your own. I think recording today it is not required. Definitely tomorrow I will share the recording, video recording. If you have any doubt, you can ask. 10 kilowatt design is not different from 100 kilowatt design. Already told, 10 kilowatt design is not different from 100 kilowatt design. The design procedure is same. Design procedure for yeah, sure. I will share the video tomorrow. You can ask if you have any doubts regarding to design or anything. You can ask your doubts. Tomorrow session is on solar protection, solar power system protection. It is also the protection is also important for solar PV system. That's why I included the session protection of solar PV system. Tomorrow session. Yeah, sure. Yeah. So the economic evaluation. So already told. So this is our project. This is our 100 kilowatt project. So when you click on the economic evaluation, then it will give this one. So here not a difficult task, but you should have the all the cost components. You should have the all the cost components. Then only you will get the exact cost. If you are including a, example cost like a WAG cost, then it will not give accurate cost. So you have to know the PV module cost exactly, inverter cost. Just you have to enter the values. That's it. If you are, this is loan, how much loan you have taken from the bank to install the, this is investment cost. So everything, and you have to know the, this installation cost, insurance cost, land cost, all these things. So just you have to enter the values, then click on OK, then it will give the economic evaluation. So that is not a big deal. So see here it is maintenance cost, land rent, insurance, bank charges, all this you have to know. All this you have to know. If you know the values, just enter here. Just enter here and click on OK. Then it will give the, after simulation is over, then it will give the how much investment cost is there. That will give detailed report. Sir, we will think and will tell you, sir, whether this link is available for today or completely. We'll let you know. We'll let you. System that is depends on sizing, sir. that is depends on your inverter sizing. You have to include the inverter sizing, solar module sizing. We are using the battery, then battery. Okay, so solar module cost generally taken rupees per watt. Battery also you can take per watt per rupees per watt, and inverter also you can take rupees per watt. So if you know that rupees per watt, for example, 10 rupees per watt, solar cost is 10 rupees per watt. 100 watt panel, 100 into 10, 1000 rupees. So you have to know the rupees per watt, then you can calculate the solar pump. The cost, sir, that means here designing, if you know the designing, then you can easily done the cost analysis. That is not a big deal. Okay. So the economic evaluation, it is not a difficult task. Just you have to know the all the cost. Then it will be easy for you. Yeah, tilt angle. Tilt angle means right in the orientation. So this is your module, solar module. You have to first know the orientation, in which direction you have to place your solar module. Okay. In the first day, I will tell you, I already told that the northern people have to locate the solar module to south direction. Southern people have to locate the solar module north direction. We are living in northern hemisphere, so you have to place this solar module south direction. That is called as the orientation. And you have to place, you don't have to keep this to the horizontal. You don't have to keep the solar module on surface. Then it will not collect the maximum power. So you have to place this solar module with some inclined angle. That inclined angle is nothing but the tilt angle. So the tilt angle that will be equal to, this is just thumb rule. The tilt angle will always equal to the latitude of your location. Okay, here for my Warangal location, the latitude is 18 degrees. So if you click on 18 degrees, then you can find out how much energy collected by this solar module. This will be displayed here. So the tilt angle, that latitude will give the idea. Okay, that is the near optimal value. So you can change your latitude so that you can find out how much energy collected by your module. That is about tilt angle. Right. So you can measure the azimuth angle by using the compass. By using compass, you can measure the azimuth angle. You require a compass. Yeah, the cost of, we cannot tell the cost of solar panel exactly. Why? Because it is changes from location to location and manufacturer to manufacturer. Technology to technology also, the cost is changes. So we cannot tell cost. That's why I'm not going into the cost analysis. So cost analysis is not a big deal. If you know the cost components, then just you enter the values, you will get that one. Yeah, subsidy, the central government will give the subsidy, but my suggestion is better directly go for the manufacturer. Always, I think the subsidy will not useful. In my point of view, the subsidy will not useful. And the subsidy will not available for all of you also. They will give the subsidy for particular period of time for particular locations only. They will not give the subsidy for all. So my suggestion is don't go for the subsidy. Yeah, they will give 30%, 20%, 40% like that. Yes, there are so many hurdles in subsidy. You cannot get a subsidy easily. Yeah, there are so many manufactured companies are there in India. Right. I hope you will do this assignment and do this assignment, send the report, PDF report to me. Then only I can understand you have done this one. If you send the PDF report to me, then only I can understand you have done this assignment. Yeah, raw material is exporting from China. I hope you will send the PDF report after done the simulation of solar pump sizing. You have any doubts or shall I close this one? If you have doubts, ask me, otherwise I will close. Yeah, please send the report. Please send the report. PDF will be generated. Send that report to me. You cannot use this software in mobile. It is not supports. In mobile, it will not support, I think. So there are some requirements for the software. So the software requirements are mentioned in the. So these are the installation requirements. So with these requirements are satisfied only, this is the required computer configuration. Okay, you can go to the required computer configuration in the PVSys data website. If this computer configuration is meet, then only it will work. Head calculation that we have chosen, that is head calculation, the static head that we are asking total dynamic head. In the first step, we have chosen the static head. We have chosen the static head, that is from top of water surface to ground surface, that is called as the static head, and from top of ground surface to your overhead tank, that is the suction head. So static head plus suction head plus frictional losses, that will give the total dynamic head. This total dynamic head actually required for pump sizing. So how can you calculate frictional losses means there is a formula, direct formula. So if you substitute this all these values, then you will get frictional losses. Then how much we are getting? 0.297. Just add all this 40 plus 7 plus 0.297, that will give 47.297. This is total dynamic head. So I think the software cost, I think in per annum it is 1.5 to 2 lakhs, I think. Yeah, you can see here. Now the seventh version is there. So you can see this. Per year it is. Right. I will share the feedback link in WhatsApp group. You have any doubts? Shall I close the session? Yeah, 30-day trial version is there. 30-day trial version they will give with full features. Yeah, 30-day free trial version. 30-day free trial version that is with full of features. After 30 days, you have to pay to get the full features. Okay. If you have, if you don't have any doubts, I will end the session. And remember, today your assignment is you have to design the solar pump, and after that simulation, send the report to me. This is, I am telling, this is for practice purposes. If you do the practice today, then it will be remember for you all the time. Right. Thank you, all of you. Okay, today's session is over. Tomorrow we'll meet. Thank you once again. Okay. So some of us don't have laptops and PCs. Okay, not a problem. But who have the laptops, please do this one. Maybe some of you don't have that one. Plus, but who have the laptops, please do this assignment. That is for you only, I'm telling. Okay, thanks once again. I'm going to end the session. Thank you.